Okay, so I'm going to talk about Gitops. You heard about Gitops 1,000 times, but I want to talk about extending Gitops a bit further than just using it for applications running in Kubernetes. Now, quick introduction. This is me after visiting one of your companies. I work for Upbound. I have a Twitter handle. I'm part of some groups. Doesn't really matter. I have a blog and books and stuff like that. Doesn't matter. What matters is that I'm going to talk about what Gitops is and what is not and how we can extend it and things like that. So, in a very simple form, Gitops is all about defining the desired state and putting it in Git. And then letting some other Santa's little helpers or processes or something else figure out how your desired state can be converted into the real state, whatever that real state is. And that real state or actual state can be many different things. So essentially, if you talk about Gitops tools, not the process, all the tools are about converging the actual state, something that exists, something real, into the desired state, into what you want that state to be. Whether that's an theoretically, for now, whether the desired state is an application, is a virtual machine, a cluster, a Lambda, serverless, something, does not really matter. The job of Gitops tools is to make sure that those two states are the same. That's all they do, right? Now, and I think that this is important since until maybe half a year ago or a year ago, every single company, every single vendor was inventing what Gitops is. You know, if you have a tool that is doing something, whatever that something is, you just put a sticker, this is Gitops. Everybody was having Gitops tools, which is not true because since a while ago, we have open Gitops, I think it's .org or .com or something like that, that defines clearly what Gitops is. And what it is based on 4 principles. We define the desired state as declarative, in declarative format. We need to make sure that we have versioned that state and that state is immutable, meaning that you're never changing that state. In the same commit. It is pulled automatically. This is very important because if you see some of the pipeline tools, you know, like Jenkins or CircleCI or this or that is saying we're Gitops because we execute kubectl apply, it's not, because it needs to be pulled. And that's very important for many different reasons, which we can discuss later if you ask the question on Slido. I assume for now that you more or less know what Gitops is. And finally, continuously reconciled. Now, continuously reconciled is a very important thing for 2 reasons. First, because it's cool. It means that those tools are continuously comparing those 2 states, right? Typically in the past, what we had is typically pipeline that is executed whenever you push some commit to a Git repository or SVN if you're older, and if you're very old, then CVS. And then as a reaction to you changing the state in some source code repository, those tools would do something. This is different, right? Gitops tools are continuously monitoring those 2 states. And as a result, that means that if something changes in your actual state, let's say a node goes down, or somebody, a junior developer or junior engineer that you just hired goes to AWS console and clicks a button, being continuously reconciled means that those tools will always undo the changes or undo the damages. Now, virtually all the Gitops tools we have right now, which is 3 in total, it's very easy to calculate, which is Argo CD, Flux, and Rancher Fleet. There might be 4th I never heard of, but let's say 3 for now. They're all based on the same ideas, and those ideas are that Gitops tools are developed as Kubernetes operators, and that makes a lot of sense simply because Kubernetes itself already gives us mechanism, does half of the work that we needed to do, and shortens the development period of such tools. Mostly that drift detection and reconciliation, right? Kubernetes already has a baked-in mechanism to detect the changes in something and to reconcile those changes. So all the Gitops tools right now are based on all the Gitops tools that you should be using, I don't know what other people are saying that are Gitops tools, are based on Kubernetes operators. And as a result, actually not as a result, the reason why that is happening is what I mentioned before, drift detection, reconciliation, and also extensible API. That API makes actually Kubernetes very special because it allows us to extend, there is a baked-in mechanism to extend what something is, right? We can create new custom resource definitions, and if you go and use Argo CD or Flux, you will see that actually that's used heavily. So now, the important question that comes for when using Gitops is, who's using Gitops, by the way? Only 1/4, shame on the rest of you. Well, what the heck are you doing? It's been like 4 years. Are you SSHing into servers, right? And the kubectl apply. No? Hiring some junior developers in India to do it for you. Okay, there we go. No, and it doesn't have to be India. It can be US as well. That's okay. So what is happening really with Gitops, those of you who are practicing it right now, most likely you're using Gitops only for applications, exclusively for applications. And moreover, you're most likely using it only for applications running Kubernetes. And that comes from misunderstanding what Kubernetes is, right? We all somehow picture that Kubernetes is designed, is a tool, is a platform that is designed only and exclusively to run containers. Right? Which is absolutely not true, right? Running containers is just one of the many, many different implementations or extensions or baked-in mechanisms in Kubernetes. And to make things even more complicated, if you think about Gitops, not the way how you implement it, but what it's supposed to do, Gitops is not that actual state that I was talking about in most of the cases, right? If you have Lambda, then desired state is what you have in Git. The actual state is Lambda, right? Or a cluster or a virtual machine or whatever you have. And Kubernetes is just intermediary. How that something can happen, how that's where the process is running and comparing those two states. In reality, actual state, if you use Kubernetes exclusively, is containers, is external load balancers, it is storage. But more often than not, it is, where was I? It is also databases, right? Anybody having stateful application has a database, and that database, whatever the kind of the database is also the state that you need to define something, somehow. And that database might or might not be running Kubernetes. If you're using Oracle, then it's definitely not running Kubernetes. It could be applications that are not in Kubernetes. It could be servers, clusters, third-party application services, and finally, maybe Kubernetes itself. So what you're trying to do with Gitops is only partially, small part. In a small part, it is a destination in Kubernetes itself. So the question that we are asking for a while now is why only applications, right? And the reason why we're asking those questions is because everyone who's using Kubernetes, if less than half of you answer, I'm using Kubernetes, I'm going to freak out. Less than, okay, now you're faking it, only not to disappoint me, right? Okay, I get it. So Kubernetes can be extended, API can be extended with custom resource definitions to do anything you want, right? And whether you know it or know, everybody, all of you who are using Kubernetes, and all of you said that you do, are already using custom resource definitions. Whether you know it, whether you made it yourself, or use third parties, are different questions, but you are, all of you extended capabilities of Kubernetes. And what we really, really need, and what I'm going to show in a demo in a couple of seconds, no, this is boring. Yes, this is what I'm going to show. Crossplane, right? The idea behind the project is to use Kubernetes with all the benefits, all the things that you like about Kubernetes, and extend it to manage whatever you want to manage, right? Whether that's applications in Kubernetes, whether that's Lambdas, whether that's Google Cloud Runs, whether that's virtual machines, load balancer, storage, doesn't matter what it is. The point is to extend it, and we can do it with Crossplane. And Crossplane happened to be contributed mostly by Upbound. I have to say that because marketing of my department is paying my expenses. There's a booth over there, go there. the more you go there, the more they will be happy and send me to the next conference. Okay, enough of marketing. I'm going to skip the setup and jump straight into demo. And demo, I'm going to show you how I can use Gitops to manage everything, right? I will not manage everything today. That would be too much, but a few things. I'm going to use Crossplane, which is awesome, and I'm going to use Flux. Now, what I'm showing you with Flux equally applies to Argo CD or Rancher Fleet. Don't start asking your questions on Slido why Flux instead of Argo CD. Actually ask it, and I'll tell you. Anyways, and by the way, this podium is made for very small people, so I'm going to have to do this. Don't ask me why. It's kind of obvious, right? So, let's start by creating a cluster, right? I'm going to do everything Gitops way. And to create the cluster, I'm going to, where is it? Infra examples, no, infra clusters production, right? So I want to create a cluster. And to do that, I'm going to use from now on Flux with Crossplane. And I'm going to use a definition like this. Now, this definition says, hey, I want to claim a cluster. Now, by the way, I made a mistake. I'm not doing introduction to Crossplane. I assume that all of you know what Crossplane is. I know that you don't. Fake it for a second. So I'm going to explain very quickly. What we do with Crossplane is allow you to create new custom resource definitions and controllers to define what it means to have something in your company, right? We call it compositions, meaning that if I would like to create a cluster in AWS, as I'm doing right now, I would need to create a EKS cluster, node group, VPC, subnets, internet gateway, bunch of stuff, right? So somebody in my company, I'm role-playing right now, created something called cluster claim and said, okay, Viktor, whenever you want to create a cluster, you just need to define this simple YAML. The magic will happen behind the scenes. I will show you the magic. And that's what I did. I said, okay, I'm going to use your composition, something that operator created in my company. I'm going to define something called cluster claim. I'm going to use labels to specify where I want that cluster to run. In this case, AWS EKS, right? That depends on whomever designed that, how many implementations there are. I'm going to define a couple of parameters. I'm saying I want to have small nodes. I have no idea how AWS works. I do not know whether I should do T2 something something or T3 something something. Nobody knows those things in AWS. I'm going to define what is the minimum number of nodes and the version. And finally, I'm going to say, hey, when you create that cluster, I would like to use that cluster. And for me to use that cluster, I need to get credentials of that cluster. And I would like those credentials to be stored in this secret. So I was about to say I'm going to just do that. I'm going to now push this thing to Git. I'm not going to do that for a simple reason, because it's AWS. And in AWS, nothing happens instantly, right? It takes around half an hour until the whole cluster is created. So I'm faking it. Imagine that I actually pushed those changes last night before I went drinking with the rest of the speakers. Instead of, imagine that I just pushed that to Git. Flux, which is running in my management cluster, detected the change to desired state and created all the resources that I need. As a result, I have, you can see here cluster claims. You can see that my cluster is up and running. It is ready. The control plane is ready. Node pool is active, and everything else is working. And to see that, you remember that definition, those 20 lines of YAML. What happened is that Crossplane behind the scenes converted that simple YAML into everything you need, and it was Flux who actually detected those changes to Git and applied them to the management cluster. Now, it takes a minute or two until it wakes up, because I have really, really cheap cluster here. I'll get back to that, maybe. Until then, let me show you what, just to show you that I'm not faking it. What is this? macOS, I don't know. There we go, right? No, that's not the one I wanted. GitHub.com/ No, that's not what I want. Okay, wrong slides. Doesn't matter. It's in Git. Trust me. Yeah. So I need to now wait until this wakes up. What the heck is going on? Demos always fail. Okay, start typing your questions in Slido. Entertain yourself until this happens. It will happen eventually. Maybe. Is Matthias in the crowd? He's a product manager of Crossplane. He's supposed to fix this. No. Okay, there we go. There we go. Maybe. Who knows? See, this is the moment when my girlfriend, almost 5, told me that I should learn some entertainment tricks like dancing or singing or something. Anyways, that YAML that I showed you, I pushed it to Git. I did it in advance because it takes half an hour until the AWS creates everything. And those 20 lines of YAML, Flux synchronized it with the management cluster, and then Crossplane said, okay, so you want to create all those things. And those are all the resources that were created for me. You can see subnets, internet gateways, route tables, VPC, security groups, and so on and so forth. But you as a user, you as a developer in your company, you do not need to worry about. You worry about that defining whether you want small nodes or big nodes or whatever you want. Now, this is all too simple. So I created a cluster. I did it in advance. I was faking it a bit. Now let me show you how I can deploy the applications. And I can do that. Where are we? Here we are. I can do that by creating something like this, right? I'm copying and pasting like every good developer does. So now that I have a cluster, I want to deploy my application, right? And imagine that I know nothing about Kubernetes. I know not that I don't know nothing. I'm not an expert in Kubernetes. I'm a developer. I'm not an expert in AWS. But I want to have a backend application. And I want that backend application to be connected to a database running somewhere in AWS, Postgres, let's say, right? So what would I do, right? I would define YAML like this. I would say, hey, I want to claim an application. And again, this is what the ops person or SRE in my company or DevOps or whatever we're called today defined. I'm saying I want to claim an application. I want that application to be this type, backend with the database, and I want it to run in the same cluster. And I'm going to define a couple of parameters, like what is my image, and I'm going to claim a database, right? In this case, I want the database running locally in my Kubernetes cluster. Later on, I'm going to show you how you can have a database running in AWS. Now, what this is what you define, not you, SRE in your company, or sysadmin, or ops, whatever the people are. So, anyways, the most important thing here is that when I create a database, I'm saying I want the secret with the credentials to the database to be stored with this name so that this application can use it. And I'm going to store that in a file. I'm going to push this to Git, right? Pushing it to Git. And I'm going to tell Flux, you do this once and never again in your lifetime, but you need to do it once to tell Flux, hey, from now on, this is the repository that you should monitor, and whatever I push into that repository, into that specific directory of the repository, you should synchronize. You should always keep it in sync, right? So I'm telling Customize, hey, this is the source, this specific repository, Flux system, sorry, repository is already defined there, and the path is DevOps, right? Dev-ops. Flux find it out, and now if you look in my cluster, you can see that there is nothing over there, right? There is nothing in this specific namespace called up claims, SQL claims. And the reason why there is nothing is because Flux did not yet go through the loop of synchronizing what is in Git and what is in my cluster. It will do that soon. See, now it appeared. Flux figured out that I pushed some manifest to my Kubernetes cluster, sorry, to my Git repository, and it applied upclaim and SQL claim. And in the background, now it's Crossplane job to figure out how to convert that something into real deal, whatever that real deal is. And that real deal, you can see here, right? Those two resources were converted, or will be soon, come on, into pod services, deployments which created a replica set created pods. There is a stateful set over there. This is my database, this is my application, these are the services so that they can talk to each other. This is ingress so that it can be reached from outside, and those are the secrets required to connect to the database, right? That's the part that Crossplane did. The job of Flux was to synchronize Git with my management cluster. The job of Crossplane was to convert those compositions into real resources. They're not yet running, but I don't have time to wait. What I will do is go to that cluster, probably. Yes, I'm going to skip this. I'm going to do this. I don't have enough time. Skip, skip, skip. What does matter is that I want now to move that application to production. Right now, my application is running in development environment. It is having a locally running Kubernetes database, database in Kubernetes, and it is having application with all the resources required for that application. Now, let's say that I want to move that to production. But production is never exactly the same as development environment. In this specific case, my production is going to be RDS database in AWS, while development is a local database. From development perspective, it's simply faster to run it locally, but production simply is going different. So what I'm going to do is define a new directory, produps. I'm going to paste this thing, pretending that I brought it myself, which is the same, right? So there is no virtual difference, almost no difference between what you saw before and what you're seeing now, except in the only difference here is in the database, SQL claim. I'm saying, hey, this time the provider is AWS. It's not locally running database. The database is PostgreSQL and a few parameters. So this line here is virtually, I believe, the only real difference apart from the namespace compared to what I had before. And I'm going to, do the same days. Copy paste, push to Git, declare it to tell Flux that it exists. And now this time I need to do one more thing. And that one more thing is this is a problem with, not a problem, downside or thing I don't like about Flux CLI. It doesn't allow me to specify kubeconfig through the CLI. By default, Flux always assumes that what is running is in the same cluster, but now I want to go to a different cluster to production. So I will modify Flux definition and say, what am I going to say? I don't remember, but I have it written, kubeconfig, and what was it, secret ref, and name is production cluster. So I'm telling Flux, hey, you're running here and Git is there, but what I want you really to do is not to synchronize inside of the same cluster, but go to production and do stuff there, whatever that stuff there is. I'm going to save this. No, that's not how you save. I'm going to, what's happening here? Save this, no. Escape. Now, MacBook escape. Unclickable. Apply it so that Flux knows about the new cluster, the production, cool, and I'm going to now check in that new cluster. This is now production. You know it's production because for production cluster, I'm specifying kubeconfig for production, and you can see that it was already synchronized 7 seconds ago. Same thing as in development cluster. Now, the major difference here is in this SQL claim. This time, even though I didn't change really YAML much, I instructed through labels Crossplane to actually create a database and manage the database in a different place. And that different place is AWS. And if I list the managed resources. This is the part that takes a minute, so it will happen. You will see soon, and this is the end of my talk anyways, I will show you later, you will see that AWS database was created. And I never touched the cluster, right? This is the important thing. All I did all the time was create what it means to have something to crossplane, a composition. This is how you deploy applications. This is how you manage clusters. This is how you do this. This is how you do that. You push this to Git. Flux, in this case, or Argo CD or Rancher Fleet is synchronizing it, and crossplane creates the resources. Oh, there we are, right? You can see here that this time I'm creating a database in AWS. And you can see because state is creating, it will take approximately, I think, 5 minutes for AWS to wake up and do what needs to be done. I'm not going to wait for that because I don't know how much time I have, and I'm not following that guy who is supposed to signal me, signal how much it takes. Thank you so much for listening to this. Do I have 3 questions in Slido? 3 minutes, that's how it works, okay. I don't know, go to Upbound, check crossplane, do all the stuff. This is my YouTube channel, check it out. I'm supposed to put a slide over there, which I forgot because I was drinking last night, that you're supposed to visit our booth, which is just outside this door. Do that without a slide. Time for questions.
Thank you so much for this talk. I think we have questions on Slido, I guess.
Yeah.
And we have,
why Flux instead of Argo?
Yeah, we have many questions, so I'll leave up to you to answer them.
Okay, so why Flux? I like both of the tools. I like Flux, I like Argo. And the reason why I do this is because I'm alternating. Next talk I will do in Argo CD, with Argo CD. No, so if you ask me why not Rancher Fleet, because it's not good. But Flux and Argo CD both are equally good with slight pros and cons. Sorry, Rancher folks. Everything else in Rancher is great, though. Who or what creates the very first cluster? Am I supposed to read or you want to read? I can go either way.
No, why not?
Why not what?
Why should we moderate it?
Okay. Who or what creates the very first cluster running crossplane and accepting the CRDs? Great question. It's a chicken and egg problem in a way, right? So crossplane needs the Kubernetes cluster to run, and without Kubernetes cluster, without Kubernetes cluster it cannot run, but you're supposed to create a Kubernetes cluster with crossplane. Now there are a couple of ways how you can solve the chicken and egg problem. Since everything is declarative and what's not, you can create a local cluster using Rancher Desktop, my favorite, or see, I like Rancher, or Minikube, or whatever you're using. Install crossplane over there. Apply some YAML, some manifest that will create your real cluster in AWS, Azure, on-prem, wherever you want. And from there on, you can just tell that new cluster to manage itself. So there is a bit of additional work at the very beginning, but then all are the benefits later on. Alternative to that is that there is also managed control planes in Upbound. So if you don't want to do that part yourself, you can just go there, sign. I think that you get it for free, initially at least. Afterwards, we suck you dry. And so, yeah, manage control planes, or you create it yourself. You can use local Kubernetes cluster and just move it to the real cluster that you create with crossplane. Is crossplane a replacement for Terraform? Yes, except that crossplane does much more, right? Much more than Terraform. It has drift detection, reconciliation. It has API. It allows you to create compositions, meaning that which are somehow similar, but not really, to Terraform modules. So yeah, it's a replacement for Terraform, then plus, and one more plus. Is there a UI? Who asked that? Very. Reveal yourself. No, it disappeared. Did you delete the question? Okay. Where is it? Okay, what's next? I don't know. How do you handle breaking changes in managing stateful resources, for example, a version change of database? So you cannot have breaking changes. I mean, you can have breaking changes as long as you accept that breaking changes means incompatible releases, incompatible APIs of something, doesn't matter what that something is, and that results in a downtime. So breaking changes means downtime. It's as easy as that, right? You should try to avoid that as much as possible. I expect that nobody has really breaking changes more than once in a couple of years or something like that. Otherwise, you're in deep trouble. In what way is using crossplane better than just creating CRDs and operators? First of all, because crossplane gives you the controllers that manage something like AWS resources or Azure or Google or whatsoever. If you would create your own operator, you would need to figure out and implement the communication with the API on the other side. Second is because those CRDs understand the dependencies between different resources. You cannot do this with the application until database is created, and after database is created, it should create a secret with authentication, and when that secret is created, then it should be attached to the applications and things like that. So there are many things that I cannot say you cannot do with operators. Everything you can do with operators, starting from scratch, you can do, of course, but it simplifies things a lot related to management of resources of any kind. Does crossplane allow for secrets to be hosted in Vault, etc.? Having a management cluster with secrets to host state is too scary. Absolutely. You have, this is moving too fast. I don't know, whatever was that question. What you can do with secrets, first of all, crossplane itself or Upbound, I'm not sure. There will be a solution released, probably by KubeCon, maybe, to have kind of like native support for secrets in Vault and other storages. Until then, or after that as well, you can use external secret CSI driver or secret storage, I don't know the names, or external secrets as well, what was previously GoDaddy stuff. I love that. And that's the advantage of crossplane compared to non-Kubernetes native tools, right? If you have some other tools which I'm not going to name, you need to look for solution for specific problem, like secrets within that tool set. In case of crossplane, it's Kubernetes native. So whichever solution you want to manage your secret in Kubernetes, you can use it. Whichever solution you have in your Kubernetes to manage logs or monitoring or this or that, you can use it. Simply, you can combine crossplane with any other Kubernetes native tool, which is basically 99% of CNCF landscape and beyond. No, and it will never do that. OpenStack.
We have a lot of questions, but sadly we have to get to the schedule. So
we can just cancel the next talk.
I'm sorry, we can't.
No,
no, we can't.
Okay.
This is not an option. So if you have any questions, then you just,
around the corner is the booth. Come there, don't come to the next talk.
And please, a big round of applause for Viktor. Before you leave, we have a special gift for you. You heard about it, so it's the Hamburg deck card.
Nice.
If you want to play with it, kids.
Very cute. There is a chick on the back.
Yeah.
Okay, cool.
Thank you very much.
Thank you.